today we're fortunate to have the CEO of Allevi, Ricky Solorzano. I hope I'm saying that name right. To have a couple minutes with us to interview. And thanks so much, Ricky, for taking a couple minutes out of your busy days to talk to us. I just received your written interview today, and then, I think it's much better to have a kind of in-person conversation to bring the audience closer to our speakers for the conference that's coming up in a couple of days, really. But Allevi has been really around for many years, and is probably one of the, I would say, cornerstone of bioprinting industry. Do you want to just, share with us what the early journey of founding Allevi, what got you into this bioprinting business?
Yeah. So, well, Jenny, it's always great to be associated with 3D Heals. It's an awesome community. We're huge fans, and we love the brand and kind of the stories that it shares. So a little bit about back in the early days of Allevi. I mean, at the time, really desktop 3D printing was coming to more mainstream, more of age. I think 3D printing had been around now for some years, especially with bigger companies like Stratasys and 3D Systems. But these kind of smaller, powerful, easy to use devices were becoming more popular with companies like Form Labs, MakerBot, Markforged. And so, they were doing really well. And, noticing that wave that was happening, no one was really riding it for bioprinting. And so we had some grounding within the RepRap community. And so we applied building desktop bioprinters to bioprinting, which is really what set it off, I think, and set off being able to provide scientists the access that they weren't able to afford, as usually there were only really kind of more expensive and larger based units on the market at the time. So it was a combination of all that together that I think was really what set off the spark and began the trajectory of where we've been able to get to today.
Yeah, I mean, this is an interesting conversation we're having because, I'm from the healthcare side and you're from the scientific community side. And really bioprinting only got into my radar is only the last couple years. So the RepRap movement that you were talking about, and whatever Jordan Miller was working on and a bunch of other scientists, I didn't know about it at all, right? Those are the time when I'm actually in my medical training as a doctor. And that I didn't know until now. I suddenly felt like I'm crossing our path. And so I think that part of the history, I mean, if you don't mind, do you mind of just talking a little bit about RepRap and what year was that and how did you got into that?
Yeah, so that was around, I think RepRap, I can't date back to when it started, but I was kind of joining it or understanding it back in 2013, 2014. And it was really just this idea that you could make 3D printers by printing them out of other 3D printers. And so they would replicate themselves. And that's the word rep in the word RepRap. But it was very much a maker community. It was the maker movement really that was driving all of the ideas. And it was really at the heart of it was placing the information online so others could learn about it and learn how to build their own printers and learn how to, it was kind of from the ground roots movement of making 3D printers themselves. And so I got involved. So Jordan, I used to work out of a lab at the University of Pennsylvania, Dr. Christopher Chen's lab. It was a great lab. It was fantastic. It was like 50 people. We would come together every week. We would just talk about patterning cells and tissue engineering and what it meant to try and think about making tissues. And so it was really awesome. And Dr. Jordan Miller was also part of that lab at the time as a postdoc.
Yeah, I'm so surprised to hear that, actually, that you guys crossed paths.
So, yeah, I mean, it's kind of it was an interesting world and how it's expanded since then. But he had built his own 3D printer, and he was using it in the lab to print out to print out sugar in the form of sugar glass, which was great work. And he published that in Nature. And I think that really set off his career. And so I was fascinated, though. It was awesome. I mean, being able to see kind of this, it was like bare bones, wires everywhere. It was kind of crazy, but it still had this, sense of creativity. You could design something on the computer, you could get it out, and he was applying it to ideas in biology and tissue engineering and blood vessel creation. And so, so I asked, there was a bunch of broken 3D printers around the lab. And so I was asking him, oh, can I buy one of these? Because I figured it couldn't be too expensive. He's like, oh, you should come down to the maker shop downtown. It's called Hive 76. And, I can show you how to, put some together and things like that. And so he helped introduce me to the RepRap community there. And I think it was Hive 76, that makerspace. It was like a bunch of unique minds coming together in a sense of revolution, like we're bringing the power of being able to build things ourselves. And they would build all kinds of things. I mean, there were like stereo systems with a TV in the middle, you name it, they would hack it together. They were just hackers. And so this hacking community was really awesome, and a sense of, a sense of creating things for the fact that it's awesome to create, and that's really what it was. So.
Yeah, it's interesting to hear that how you look at creativity and what, that is part of the inspiration for you to go on this path. I actually personally do believe that creativity and human survival, these are two innate instincts that we have. It's the need to create. And now that you have this powerful tool, but you basically were trained as a biologist in a way, right? So tissue engineering, I guess, biomedical engineering, I don't know how to categorize, but tissue engineering. So you suddenly discovered this amazing tool. And how did that transition into forming a company in the dorm rooms?
So I think, well, there's this really awesome movie that I saw way back when. It's called Something Ventured, and it speaks about.
I watched that.
It's a great movie. It speaks about how individuals were able to take engineering endeavors and create them into successful value through companies. And so at the time I was I had graduated college, and I was taking a gap year, and we had we had this plastic 3D printer, and we saw this opportunity that, hey, maybe some people would be interested in printing biomaterials, printing just gels. And so one thing led to another. There was a competition that was around, and we entered the competition. And then they said, why don't you try selling this? And so all of a sudden, this tinkering that we were doing in the dorm room, or in the room really, became all of a sudden an idea of, well, we just made this device, and let's see if we can sell it. And so we sold one. We sold, and it was exciting. I mean, it was like, oh my gosh, which is a whole different story. But because as an engineer, you're like, oh my gosh, I'm gonna, sell something. But we sold one, and then we built another one. We sold another one, and then, in tandem with what the movie has, they asked for investors, and so we understood that if we wanted to continue to grow this at a faster pace, we were going to have to get investors and form it into a business and make something more sophisticated out of it. But that's really what's provided this structure of the business is what provides the value to the entire community today. And I mean, the team that we have is also incredible. So
yes, I can feel it. So tell us, where is Allevi? I guess that's the right way to pronounce it.
That's how you say it. I mean, I think it goes back and forth. But we add the accent on it, and for whatever reason, we say Allevi, even though it comes from alleviate. But
right, exactly, alleviation. But Allevi sounds French. Okay, I guess that's more sexy. So tell us where the company is at right now, and what are your goals for the near term and longer term?
I think the company has an amazing team today, and I think a lot of people ask, oh, what was the founding story? But honestly, the team that we have has been able to take the product and the reach to such a greater height, and such a great group of people. And collectively speaking, I think the goal is really to continue to mature the technology and really just, that adoption curve. And so we want to climb the adoption curve in terms of having an impact. And we realize that to do that, we have to continue to create standards and reach populations that are larger in number. So when we started off with the engineers, and so and even beforehand, the material scientists, they're the smallest population, but the earliest thinkers. And the tissue engineers, we've come to do well in serving them. And now we want to serve the biologists and the individuals involved in drug discovery. And we realize that it's important to do that because that's how we can have that impact. We can make that contribution, but it requires standards, and it requires a sense of, plug and play almost is always the word we've come. And that word is also evolving in terms of what plug and play means for bioprinting, but being able to apply more standards, allow people to access the value in a faster way is really, as a team, what we're collectively working on. And then education, which is really, half the battle is sales, but half the battle is education, being able to show this is what the value is. This is why it's valuable to you and why you should use it today. And so that combination of is really what we're focused on, maturing the technology to biologists and drug discovery.
Yeah, I think the understanding of bioprinting in general, biofabrication by the public is still very rudimentary. So education is definitely huge. I mean, that's part of the reason that we're doing this conference, is to bring our understanding deeper. But you also mentioned a really interesting element is this is a multidisciplinary approach. It's not just one, profession like biologists versus material scientists can achieve alone. This is something that you really need to learn how to bring these people, usually have nothing to do with one another, and now together in one single team. And that's definitely a challenge. And you also mentioned that the latest advance with Allevi is software development, which is interesting point, because I can feel that this year, in the last 12 months or so, there is I can palpate that there is a movement in the software side for biofabrication and bioprinting. You want to elaborate why that's important to you guys?
So my thoughts, it's a collectiveness of the interdisciplinary aspects of the engineering that make the experience to be able to get to a 3D tissue. And so you have the printer, you have the software, and you have the materials. Software in general has seen a lot of, I'd say, innovation and activity because of the idea that, it's growing towards a workflow, or growing towards being able to achieve greater design complexity, but without that much complexity from the software. So the software has become easier, but you could do more with it. And so being able to, that's going to be a continuous trajectory, because it's almost like a computer, right? So instead of people having to write the code, they can now, click on an icon and it does things. And so it's that same idea in terms of design, which is really where the bioprinter gets its potential as a platform. We're able to invite other minds that have tremendous amount of knowledge on a specific area to contribute, but giving them that portal is through the software, and having them interpret things in a quick fashion is really what the software provides. So
I think it's critical for the field to take to scale, because I remember in 2017 when we hosted 3D Hills 2017, I was talking to a well-known professor in a large university about using a bioprinter from a well-known company, not your company, just so I'm clear. He has this really expensive machine sitting in the lab, but no one is using it because it's so complicated. No one knows how to use it. There's no instruction. And it's this opportunity lost to me at the time. I felt like this doesn't make any sense. Why is everyone else can plug in and play and not this incredible machine that could do a lot more with these smart people. So I think it's, well, the other problem with barrier of creating good software in industry that I learned recently is actually from another speaker for the software panel, Gavin White. He did some work for Trellis.
Yeah.
He's a game designer. And we were talking about, why don't we start a company just doing software for bioprinting, right? Like that sounds like low risk, scalable business. But it's actually not, because there's not a whole lot of people know how to bioprint. The market is relatively limited at the moment. I mean, it really depends on companies like you guys who have already everything lined up to develop that, and users and applications at the same time.
Yeah, I think in terms of that, it's and the industry in general, and okay, this company, it's the bioprinting industry is becoming even more diverse in terms of the technologies that are used. And so there's laser, there's 2-photon, there's SLA, there's extrusion based, there's inkjet based, and so all these have different design potentials, and so the software has to be so in tandem with the hardware, at least for now, because of the fact that you have to understand what's the value of the hardware that's going to be achieved by the software, and in combination, what materials am I going to be using that's going to provide me value, and I'm going to be able to access it through the software. And so that's kind of, I think the standards aren't high enough in terms of a software for all, or a software that can be independentized, at least for now, because of the fact that they're so in combination with the value that's being provided by the inks or the materials and the reagents and the printers themselves. And they're quite diverse in terms of technology platforms. So
well, that's why we need to continue to do research and development in this area. And you mentioned that publication is one of the elements that you guys track to see how successful a company is doing, but also how the field is advancing. Any mentionable publications in your mind in the last 12 months or so?
There's a publication that we just did a blog on that was really nice, and it spoke a little bit about, it was from the University of Sheffield, and I think it was published back in April, about being able to show not only vascularization, but angiogenesis. And I thought, it's really, really cool. Making blood vessels is a big deal from bioprinters.
Absolutely.
Not only in extrusion, but across the board. I think everyone wants to make a big, thick tissue, and so to be able to do that, you need blood vessels. And so
absolutely.
But it's very exciting in terms of the progress that's come about, and not only being able to make them, but how these blood vessels interact with the cells that are in the gels. So that's just one that comes top of mind, but publications is
I'd love to get that link from you later on and put it in the show notes or something, so that people can also read about it. Well, we're approaching the end of the interview, so I know you're actually mostly quarantined at home, working remotely. I think earlier on I saw an article in Crunchbase talking about agility, cloud-based computing, 3D printing are the ones that actually allow some companies to succeed in this pandemic. You want to share with us how your experience with this is right now?
I think it's, quarantine has pros and cons in terms of, I think in general, it's like, it's a necessity. It's something we've had to do out of adaptation. We still have to stay productive, but we have to go on and work remote. And working remote has pros and cons. You get more alone time, you get to think more, you get to brainstorm more. I think Newton had, I read this article, Newton had, I don't know, he discovered some sort of theories during the times of the plague. And I think it's the same idea here in terms of we are invited to brainstorm more, to think more outside the box. In terms of the bioprinting world, I think we're stressed to think about more of the people that are, how do we serve the people that are actually going to the labs, which are the people that are working on coronavirus. And so, we're stressed to do that. But at the same time, it's about continuing this mission, staying productive, but adapting to the times. And that's all in combination, all happening together. And a great team is still the thing that makes it successful. So
No, I absolutely agree. I mean, there are several different kinds of creativities in a pandemic like this, right? One part of the creativity is focused on emergency solution based, and the other side of the creativity is something that's completely unrelated to the ongoing crisis. Like Newton discovered gravity and all those fundamental the reasons why he succeeded in becoming professor so young in his age has nothing to do with the plague, right?
Yeah.
So yeah, and I'm very much looking forward to all the amazing work that you guys are going to do in the near future. Thank you so much, Ricky, for today's interview. And I'll
Thank you.
see you in a couple of days.
Yes, definitely. Thank you so much for having me, Jenny. It's been great working with you at 3D Heals.